Hello everyone, I am Saranjit Singh from Akal Academy Rodi. Today I will discuss chapter 9 of class ninth, that is force and laws of motion. So let's start. So today I will discuss some topics. First, force. Second, balanced and unbalanced forces. Third, Newton's first law of motion. Fourth, inertia. Fifth, types of inertia. Sixth, inertia and mass. Next is Newton's second law of motion, and the last one is Newton's third law of motion. So first is, what is force? Force is a push or pull. So these are the effects of force. So first effect is it can move a body which is at rest. Suppose an object which is at rest. So when we apply a force on that object, then object may move. Second point is, it can stop a moving body. Suppose a body which is in motion. So when we apply a force opposite to the motion of body, then it can stop a moving body. Third point is, it can change the speed of a moving body. Suppose a body which is in motion. So when we apply more force or the force in opposite to the moving body, then it can change the speed, means it can increase the speed or it can decrease the speed of a moving body. Fourth point is, it can change the shape or size of a body. And the last point is, it can change the direction of a moving body. Okay. So next is balanced and unbalanced forces. So first is, what is balanced forces? The definition of balanced forces is written here. If two forces act on a body in opposite direction and if both forces are equal, like that. Okay. So if two forces act on a body in opposite direction, suppose in the first figure there are two types of forces, first in the left direction and second in the right direction. So you can see here that the magnitude of both forces is equal. Okay, so that the resultant force acting on the body is 0. That means resultant force means left side force minus right side force. Okay, so that means 300 Newton minus 300 Newton. So the resultant force is 0 Newton. Okay. So such forces are called balanced forces. And because resultant force is 0, so that they cannot change the state of rest or motion of a body. Next is unbalanced forces. If two forces act on a body in opposite direction and if one force is greater than other, like that. So here it is, left side force is more as compared to the right side forces. So that means there is a change in the resultant force. Okay, so resultant force is not equal to 0. Such forces are called unbalanced forces. So they can change the state of rest or motion of a body. So next is Newton's first law of motion. So according to the first law of motion, it states that an object remains in a state of rest or of uniform motion in a straight line unless it is acted upon by some external force to change the state. Suppose there is a book on the table. Okay? So this book remains in the state of rest until external force not applied to that. Same way, here is a chair. So chair is in the state of rest. So it remains in the state of rest until we not applied the external force on that. So this is the first law of motion. Next is inertia. So this is the definition of inertia. So according to the definition of inertia, it is the inability of a body to change by itself its state of rest or state of uniform motion, like in the first law of motion. So this book is at rest. So it is the inability of this book to change its state. Okay, so that means this is called inertia, and it is in the state of rest or in the state of uniform motion until external force not applied. So that's why first law of motion is also known as inertia. So there is a three types of inertia. First is inertia of rest, second inertia of motion, and third is inertia of direction. So first is inertia of rest. So inertia of rest is the inability of a body to change by its state of rest. Okay, so that means a body which is at rest remains at rest and they cannot start moving on its own. Okay, for example, suppose we are standing in a stationary bus like this person. So when the driver start this bus suddenly, then at the initial stage the state of this person is the rest position. But when the driver start the bus, then then the body of this person remains try to remains in the state of rest, but due to the suddenly starting of bus, then this person feel a jerk or thrown backward with a jerk. Okay, so this is the inertia of rest. So next is inertia of motion. It is the inability of a body to change by itself its state of uniform motion. A body in uniform motion can neither accelerate nor retard on its own and come to rest. For example, this bus. So the person sitting in this bus, in the moving bus. Suppose we are sitting in a moving bus, the driver stops the bus suddenly, we get thrown forward with a jerk. Suppose this person is sitting in the moving bus, and when the driver suddenly stops the bus or applies brake, then the body of this person try to remain in the motion, but due to the application of brakes, then the person feels uh, jerk or get thrown forward with a jerk. So next is inertia of direction. So this is the last type of inertia of direction. It is the inability of a body to change by itself its direction of motion. That is, a body continues to move along a straight line unless compelled by some external force to change on it. For example, this car moves in a straight line, but when it rounds or turn left, then the body of the driver try to remains in the straight line. Okay, but because the car move rounds suddenly, so that's why this person feels a jerk. Okay, so this is the path of a passenger or path of a driver without car, means it is the uh, It is the inertia of direction. Okay, so when car turns around left, so they feel a jerk in the right direction. So next is inertia and mass, means how inertia depends upon mass. The inertia of a body is measured by the magnitude of force required to change the state of body. The force required to change the state of a heavier body like that is more than the force required to change the state of lighter body like that. Because here it is, this body has much heavy as compared to this body, so that to move this body from the rest there is a large force is required as compared to this. Okay, so that means the mass of a body is a measure of its inertia. So that means more is the mass, more is the inertia, and less is the mass and less will be the inertia. So the next topic is Newton's second law of motion. So according to Newton's second law of motion, it is the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Okay. For example, in the previous case, the this object is at rest, so the momentum is 0. So when the force is applied, so when the force is applied in the left direction and this force is a unbalanced force, so then there is a change in momentum. So that means change in momentum is directly proportional to the applied force. Okay, so suppose there is a body which is in motion having initial velocity is u. So when we apply force on the moving body, then suppose there is a change in the velocity. So the initial velocity suppose u and the final velocity suppose v. Okay, so according to the definition of Newton's second law, change in momentum is directly proportional to the this or force. So we know that momentum is a mass into velocity. Momentum is a mass into velocity. Okay, so put here, so m into v minus u, so this is the expression, and actually momentum is a rate of change of momentum, that means it is divided by t. So rate of change of momentum is directly proportional to the force, so that means written here. So proportionality the sign ਨੂੰ ਜਦ ਹਟਾਵਾਂਗੇ, then there is a proportionally constant, there is a k. Okay, so force is equal to kma. A is a acceleration, because acceleration is a change of velocity with respect to time. Change of velocity with respect to change in time, this is the acceleration. So change in velocity is v minus u and divided by t, so this is the acceleration. So force is equal to kma. If k is 1, then F is equal to m into a, means force is equal to mass into acceleration. So the last topic is Newton's third law of motion. It states that, or according to Newton's third law of motion, action and reaction are always equal and opposite to each other. For example, when a person jumps from a boat in the forward direction like that, this person jumps from the boat in the forward direction, then the boat moves in the backward direction. That means that means the person applied force in the backward direction, that is the action, and due to the reaction he moves in the forward direction. Next example, when a gun is fired, the bullet moves in forward direction. This is a gun, the bullet is fired, so that means this is a action. And according to the definition of or Newton's law of motion, action and reaction are always equal and opposite. That means magnitude is equal but the direction is opposite. So this is the action and in the right direction. So reaction is in the opposite direction. Okay. So and the gun moves in the backward direction. So thank you very much.